This is an introduction video to link-bone SMA multiplexers capable of switching high-frequency signals up to 2 GHz. First, let's have a look at the front panel of link-bone switch. The device can be controlled via infrared remote control, RS-232 serial or Ethernet interface. The user can also control the device directly via touchscreen. The system display shows internal multiplexer topology. In this case we have dual version of SMA multiplexer with 2 independent switches. On top you can see multiplexer A and on bottom multiplexer B. To change the state of the multiplexer, tap on connection diagram. Next select port to be routed to common port C. Each multiplexer has individually controlled internal 50 ohm termination which can be disabled or enabled by the user. On the rear panel of the device there are 2 multiplexers which were displayed on the LCD screen. Each multiplexer has common port C, and bidirectional ports from 1 to 8. The user can manage the switch remotely via Ethernet or serial interface. The switch can be controlled via a set of text commands useful for script automation, or via built-in website server. The device can be mounted in 19-inch rack system by attaching 2 mounting brackets on the sides. To measure the characteristics of the switch we will use a spectrum analyzer with an tracking generator. Common port C is connected to signal generator output, and port 1 to analyzer input. Let's have a look at multiplexer insertion loss. The chart frequency range is from 10 kHz up to 2 GHz. The plot represents the insertion loss in decibels. As you can see at 2 GHz we are above -3 dB attenuation point. Next let's have a look at the switch isolation graph. The frequency is in the same range as in previous measurement. The isolation over complete frequency span is below 45 dB. In this application, we have a device generating in 250 MHz sine wave signal, connected directly to the first channel of oscilloscope. The 2 other signal lines from the device are connected to the multiplexer. The common port is connected to the second channel of the oscilloscope. The oscilloscope displays the signal connected to first port of multiplexer. Now let's switch to second port of the multiplexer. We can see a 125 MHz square wave. Now let's switch back to first port of multiplexer. On the top we have original 250 MHz signal waveform. On the bottom we have signal routed via a multiplexer. There is small difference in the signal amplitude due to switch insertion loss at 250 MHz. Thank you for watching. For more information please visit our website at www.linkbone.com.